0. X is 0. So that is gone. That is e to the 0 is 1. So that's a minus 1 and plus k. So basically left hand side is 0 now, and we got the value of k as 1. Right? Take that to the left hand side. Cos pi over 2 is 0. So that 0 is gone, plus 1. Now put this value back there, and still we need to solve the equation, please. So how do we do that? Take the half, say right. That's a minus a half cos 2y is equals to minus x e to the minus x minus e to the minus x. The value of k is 1. So it's a plus 1. Just to transfer the 2 there and remove the minus, the final step should look like cos 2y equals to, minuses will go away, it's a 2x e to the minus x plus 2 e to the minus x and minus 2. That's how we can leave the answer. We don't need to make y subject in this. Even if you do that, you get cos inverse and then divide by 2, blah, blah, blah. But the examiner expects you to leave it there, I think, right? So nice question there. We did integration by parts here. That's the answer. As you practice lots and lots of sums, actually you remember the answers. Dy over dx is equals to 1 over 3y square x plus 2. Listen, copy these sums. Try on your own first. If you get stuck, then you go back and see how I have done. If you have done it full, if you got the answer, then come back and check the answer, right? Please. Dy over dx is this. 3y square left side, nice one. 3y square dy equals to 1 over x plus 2 dx. This looks pretty nice. Integration, not a long one, I think. So it's a 3y cube divided by 3. So that's simply y cube equals to natural log x plus 2, please. That's all, and plus c. Initial condition is 1 and 2. So x is 1, y is a 2. So that's a 2 cube, which is 8, is equals to x is 1. So natural log 3 plus c. Then we can find c. c is 8 minus ln 3. We can leave it like that. That's the c value. We put that back here and then find y. Okay. So y cube is equals to natural log x plus 2. That's what I have. And c is this. So it's a plus 8 minus ln 3. You can collect those two like terms in case, say ln x plus 2 divided by 3. You can do that if you want to. ln x plus 2 divided by 3. Log a minus log b. Then we have plus 8. If you remove that cube, you will have to the power, that's modulus, please, 1/3, or cube root of that, please. You can leave it like that. Okay, that's one of the exam questions. Want to try this one? See, dx over dt minus 4 x minus 8 to the power 1/3. Initial conditions I have is this. Dx over dt, I don't have a t here, so I can keep that minus 4 and say dt. Nice. Move this to the left hand side, so it should be 1 over that, or simply x minus 8 to the minus 1/3 and dx. Integration. Okay. You are good now. You can do. You have done so many sums. That's minus 1/3 plus 1. So x minus 8 to the power plus 1 is 3. So that's a 2/3, right? Divided by 2/3. So it's a 2 and a 3 on top. Reverse of the chain rule, we don't have any. Equals to minus 4t and plus, call it m this time. Initial condition 0, 72. T is 0, please. So actually that 4t is gone. We are left with m. Let's write 72 here. 72 minus 8. Take the 2 away. 70. 6 away, so we are left with 64, right? Okay, nice number. 3 times 64 to the power 2/3 divided by 2, and m value, that's a 4 cube, 4 square, 16, 8 3s, 24. All right, use the calculator, you should get the same answer. So m equals to 24. We put that back in here and make x subject if we can, right? I'm taking that equation now and substitute m as, m as a 24, please. Okay, guys, that's the green equation. 3 over 2 x minus 8 to the power 2/3 equals to minus 4t plus 24. That's what is the equation that we got. Keep the x minus 8 here. You know how to manipulate. So that becomes 2/3 here, 2 bracket, minus 4t plus 24 and divided by 3. 2/3. And then, of course, you transfer this. That should be 3 over 2 and then move 8 if you really want to make x subject. Okay. These are the past exam sums. I got few more to go, just 2, 3 left, I think. Yes. There is an interesting question based on Newton's law of cooling. I think that's, it's one of the physics textbook sums there. d theta over dt equals to k times that. All right, they gave me initial condition as 0 and 20. To find C. Well, there are 2 initial conditions. Let's see why there are 2, all right? So that comes to the left-hand side. So it's a 1 over 160 minus theta d theta equals to k times dt. Well, we don't know k, isn't it? That's why we have 2. Integration, right? That's a lovely one. It's a natural log 160 minus, 160 minus theta. Hey, differentiate this, you get a minus 1, divide by minus 1, so that's minus, is equals to kt plus a, right? That's like c. There are 2 unknowns. That's the reason we are given 2 initial conditions there. So I'm going to take the first one. They said t is 0 and theta is 20. Okay, t is 0, so that is gone. So I'm left with a equals to minus natural log. Theta is at 20, so it's ln 140. Minus ln 140 is a. That's what we put in here. And then we use the second condition that we have to find this k. Okay, so let's go back to the same equation now, which I have as minus ln, let's do it slowly, minus ln 160 minus theta equals to kt, and a is a minus ln 140. Very important, right? We don't need a modulus sign for that because it's a lovely number, ln 140. You can just use a bracket if you want. Now, the second condition I know is here, tiny, small there, watch, 5 and 65. So t is a 5. So I will write there t is a 5. So it's a 5k minus ln 140. What they said was theta is 65. So let's go ahead and substitute 65 there. So it's a minus ln 160 minus 65. So it's 100. 95, correct? 95. That's also in one bracket. That's what we have. So 5k is equals to, transfer that here, ln 140 minus ln 95. That's what I get. So 5k is equals to, you all know what to do. Log a minus log b is log a divided by b. 140 divided by 95. We can make it smaller. 5k, or just move the 5. So it's a fifth ln 5 times 19, right? 95, and that's a 5 times 4, and 5 2s are 20, and then 48. 28 over 19, and I think we can leave it like that. That's the value of k the examiner was so we need to solve this differential equation, please. Let's separate the variables. The y minus 5 comes to the left hand side, so it should be y minus, say it's a 1 over y minus 5 dy, that stays there. On the right hand side, this fraction becomes upside down, as you know, so it's a x square minus 5x and plus 6 divided by x minus 1. I think we can factorize that, but factors cannot be cancelled. So that's a dx, right? What's our approach here? What should we do means, this can be integrated, all right? To integrate this, we are in partial fractions, and that's an improper fraction. So let's quickly divide that by the denominator. So we have x square minus 5x and plus 6. Divide, you all know, so just quickly please, if we divide by x minus 1, that should be x, and x square minus x. Transfer cancelled, so minus a 4x plus 6. I think remainder should be a 2. 4, so it's a minus 4 on top there. So minus 4x and plus 4, and the remainder should be a 2. So what we are left with means this fraction can be now written as x minus 4 comes separate, right, in one bracket, and then we have plus, denominator is the 2 divided by x minus 1. So that's what we are left with. So this can be integrated now, right? So I'm integrating that, that and that, all the three of them, right? With respect to x, that's y. That's natural log y minus 5, correct? So let me write that here. So left hand side I have ln y minus 5 modulus, please, and then equals to, let's go and check, that's the x minus 4. We need to integrate, please. So that's a half x square, and minus 4 is a minus 4x, and this one is 2 over x minus 1, which is plus 2 natural log x minus 1. That's all we have. Let's leave it like that and then substitute the initial condition which we have 8 and 7. Well, there is a plus k, isn't it? So we need to find that k. Substitution, please. Y is a 7, x is a 8, so that's a 8, 8 and 8. Now what happened, left hand side, that's natural log 2, right? So we have ln 2 equals to, just watch this carefully, that's 4 times 8, 32, that's a 64 divided by 2, 32, so actually those two cancel out, and we are left with 2, 8 minus 1 is 7, so 2 natural log 7 and plus k. We can take the 2 to the top, that should be a 49, right? So k equals to ln 2 minus ln 49, that's what we have. So k is now natural log 2 out of 49, right? Once we know that it is 2 out of 49, we can substitute back into the question. No need to make the y subject, just leave it as ln y minus 5, okay? Or the whole thing now becomes e to the power. All right, so that's one model, one of the exam questions there. We used partial fractions. Just be careful there how to integrate. Question 9 is on the screen now, which is a very nice question. We have dx over dt equals to k bracket that much. The initial condition is given to me as t is 0 and x is 0. They want us to show that k equals to 1/3 natural log 5 over 4. So let's see how this is done, right? We have the questions there, I think. Yes, this is the sum. We keep the k there, so that should be k dt, dt transfer there, that comes to the left hand side. So that's 1 over 3 minus x in one bracket and 6 minus x in the other, that's a dx. So we are in partial fractions again. So what you can do now is, let's say this is equals to a over 3 minus x and plus b over 6 minus x is equals to 1. And quickly we need to do 6 minus x and b is at 3 minus x equals to 1. Let's find out the values, please. We have, if you put as 6, I think we get 3 minus 6 minus 3. So b equals to minus 1/3, right? If x is at 3, then a equals to 1/3. So those are the two values. So we go back and substitute here, please. Right hand side is just a k dt. Okay, so a is a 1/3. So now my question looks like, watch there, it's a 1/3 inside the bracket 3 minus x, and then plus, that's a plus, but b is minus, so let's write minus, and 1/3 6 minus x equals to, on the right hand side, it's a kt. If you integrate on both sides, please, that's a kt plus c. So we have two unknowns and we need to find out c first to find k, right? Initial condition we know, that's a 0 0, please, it's on there. Let's integrate this first. We did not integrate the left hand side yet. Right hand side we have done. So that's integration. 1/3 3 minus x, so it's a 1/3 natural log 3 minus x modulus. But we divide by minus, so minus comes in the front. Chain rule, right? Minus. This is 1/3, of course, natural log 6 minus x. And minus 1 again, so that becomes a plus, equals to kt plus c. That's all we have for the time being. Now we need to substitute these values, please, into the equation. Let's see what we get. T is 0 and x is 0, that's what we know. So let's substitute them into the last equation there. Both are 0 0, so that's a 0, that's a 0. So it's minus 1/3 natural log 3 plus 1/3 ln 6, right, equals to t is 0, that's a c. So if you take 1/3 common, that should be ln 6 minus ln 3, so you get ln 2. That's what we have. That's the value of c. So we substitute back into that. We can actually simplify that a little bit more. I will do that here. This one, it's, if you take 1/3 common, right, 1/3 is common, that becomes ln a minus ln b, so it should be ln, nice fraction there, 6 minus x divided by 3 minus x. That's what you get in modulus, please, left hand side. Right hand side is a kt, and we don't know the value of k yet. We need to solve that. Plus c, c is 1/3 natural log 2, so that's, plus 1/3 ln 2. So that's what we have. Now there should be another condition given in the question. What they said was, let's write here, t equals to 1 and x equals to 1. That's the second condition they gave to prove that k equals to 1/3 ln 5 over 4. So we use those two, both are 1 and 1, please. T is 1, we know, and x is 1. Right, let's see what we get here. If you substitute, that's a 1 and 1, so we get 5 over 2. Right, so 1/3 ln 5 over 2 I have equals to kt becomes a k plus, that's 1/3 ln 2. You transfer it that to the left hand side, you will be able to prove that k equals to 1/3 natural log 5 over 4 according to me. So that can be done. I leave that to you, please, right? You have done lots of sums, so that's not a big deal for you. It's not the general solution. Okay, please remember that, because we have the initial condition also. Then we have one more here. A bit complicated looks like to me, but we will see. Transfer the x's to the right hand side. Let's keep dy. So that's a 1 dy is equals to 2 sin x divided by cos x minus sin x. Right, people, there is nothing we can do, I think, with this. Okay, absolutely nothing, looks like. Substitution method, no. What we do is, let's multiply both numerator and denominator by cos x plus sin x and see what happens, right? That's a minus b, a plus b, that becomes a cos square minus sin square, right? That's cos x plus sin x. See how things change now. Left hand side is still 1 dy. I'm not integrating yet. Okay. So that's a 2 sin x. Let's open the brackets, please. 2 sin x cos x and plus 2 sin square x divided by, this is cos square minus sin square, which is actually cos 2x. Right. That's a cos 2x, please. Okay. Cos square minus sin square is cos 2x. Then that is actually sin 2x. Okay. Plus, let's leave that as 2 sin square x. See what happens. Denominator is a cos 2x. Now it looks much better to me. We can actually split this fraction. Sin x over cos is a tan 2x, which can be integrated, right? Plus that I'm worried about. All right, 2 sin square x. This is cos 2x. Right, we go back to the double angles of cos theta. So we know cos 2x is equals to 1 minus 2 sin square x. We have 2 sin square x. Maybe we can make that subject here. That comes to the left, 2 sin square x is equals to 1 minus cos 2x. That's all, guys. So now that is actually 1 minus cos 2x divided by cos 2x. We can split that. We did not integrate yet, right? Tan 2x plus 1 over cos 2x is a sec 2x minus cos 2x over cos 2x is 1. That's what we have. Okay, let's go a bit close. That's what we have. Left hand side is 1 dy. We are allowed to integrate now because all these three are good looking, right? Integrate, integrate, integrate. 1 dy should be a y and equals to tan theta, we all know, is natural log sec x, right? If you integrate tan 2 theta is natural log sec 2x, but do not forget that 2 is a half in the front there, plus sec theta is integration of sec theta, please. Sec x tan x, sec x plus tan x. ln inside the bracket, sec 2x plus tan 2x. Sorry, I'm running short of space there. And then we differentiate the 2, you get a half in the front, then you get 1 is actually x, and then plus k. No initial condition. They asked us to find the general solution only. Okay, that's how we did this question now. Just see how we attempted. I had no clue when I looked at 2 sin x and cos x minus sin x. So we multiplied both numerator denominator by cos x plus sine so that becomes cos 2x. Numerator, we split the bracket, so luckily we got sine over cos, which is a tan, and that 2 sine square x again, right in terms of double angles of cos theta, please. That's the most important one in the whole of trigonometry. Last and final question. Okay, the 10th one. They want us to find a particular solution of this differential equation. Initial condition is given to me. X and x, let's transfer them to one side. Okay, so it's actually x divided by x square plus 1. Okay, that comes there, dx. Left hand side is 2 over 4 minus y square dy there. Integration on both sides, right? That's a partial fraction, please. So it's actually 2 over 2 plus y and 2 minus y, which gives 4 minus y square. dy equals to, that's integration. This is guessing method, all right? So x on top, x square plus 1. Remember, differentiate this, you should get that. It's a over b over, if I close that, I get a half. Guys, listen, this is actually half and half. So this can be written as half. A is a half, B is a half. So it's a half over 2 plus y